Hello everyone, welcome back to the channel. Today we will be taking a look at this easy question called the Shohag Loves XOR from the recent code turn round. It is actually very mathy question, I would say, math related. There's nothing much of a programming needed here, and yes, I would definitely recommend you to try this problem on your own. Yes, so here we go. Shohag has two integers x and m, and we have to help him count the number of integers y such that it is between 1 and m both inclusive, and y is not equal to x, and x XOR y is a divisor of either x or y or both. So I assume that every one of you knows how the bitwise XOR operator works, and yes, so let us directly head towards the solution. It is gonna be a short video, but yes, so yes, I have already written the solution. So suppose your x is of length, suppose this is of length n. Okay, so this is of length n. Okay, so and this one is the leading one, and length of x is n plus 1. And suppose if my y's length, okay, length of y is n plus 2 or greater, so suppose it is 1 and capital B1, capital B2, so on up to b of b, capital B subscript n plus 1. So when I take XOR here, x XOR y, then this 0, this 0 and this 0 will give me 1, right? So this 0 and this 1 will give me 1. Okay, so and some length string, so some string of length n plus 1. I don't care if they are all zeros or ones or whatever it is, it will be of length n plus 1, because this whole part is of n plus 1 length, right? This whole part. So this whole part, this part and this part is of length n plus 1. Okay, so basically I am seeing that length of x is less than the length of this x XOR y, so it won't divide the x XOR y. Okay, so it won't divide x XOR y. Oh, okay, sorry, x XOR y won't divide the x. Okay, sorry. And let us see if it divides y or not. So first case, so let us consider b1 as 0. Okay, so here b1 is 0, so here my 1 will come, right? So 1 XOR b1 will be basically 1. Okay, so this again is greater than y, right? Because b1 is 0 here. If it is 0 here and 1 here, this thing is bigger, right? So in that case answer is no, that it won't divide y. Okay, so what about b1 is equal to 1? So here it gets somewhat tricky. So if b1 is equal to 1, our second bit will be 0, and this still won't be dividing y. Why, you will be asking? Because see, here I have drawn the example. Consider this thing. Okay, so consider, consider this thing. So a binary representation of 4 is this thing, and I've written till it 8. Okay, so it till 8, and see that so if the length of string is both, means length of the both string is same, which is 3, smaller number cannot divide the larger number whatever you do, because so suppose what, so you'll take 4, so what is its next multiple, uh, which is basically the 8, right? So how much numbers does 8 have? So it is basically binary bits, so it is basically 3, or 3 plus 1 4, so which is basically greater than 3, right, which is the number of the bits in the binary representation of 4. So you have to kind of imagine this or visualize this, that the that here, if the length of the both binary strings is same, it is impossible to, what you can say, it is impossible that the smaller number divides the larger number, because uh, any number you take, so suppose you take 6, okay, you take 6, what are the its multiples? It is 6 itself and then 12. Okay, so we don't actually want 6, right? So because this number and this number both are different in these cases, because if b1 is 1, my second bit is 0, so they both are different, so it cannot be 6, right? So next number is basically into 2, right? If it is into 2, then what are you doing? Basically you are appending one more 0 at the end. You are appending, okay, what is it called, appending or prepending? Okay, appending, I think appending. So appending the 0 at the end of the string. So basically you are increasing its length, and you don't want to do that, because both of the length of the y and x XOR y is n plus 2 here. So here we have proved that for b1 is equal to 0 and b1 is equal to 1, x XOR y won't divide y. Okay, so if it won't divide x and y, it certainly won't divide the both. So what I can notice is that, so if y, so my number one observation, or the most important and the only observation that I have to make to solve this question, is that my y is actually in these limits, and my y should also be in these limits as well. Why 2 into x? Because uh, when you do 2 into x, then only the length of the string increases, right? So you go till 8 to 15 in binary, your string length is 4, but when you do 8 into 2, it becomes 16 and the string length is 5. So basically you want to keep it below 2x, right? So y should be less than 2x. So here we can easily check, or here we can easily notice that our time complexity is O of minimum of 2 into x comma m. And will this fit? Yep, it actually would, because minimum of those both will be of order of 10 to the power of 6, and it will basically definitely pass our time limit. It will definitely pass our time limit. So that's basically just the one iteration, and your answer would be ready. So let's head towards the code to understand it well. So pretty short code, easy to follow, easy to understand as well. Input and then initializing answer, and take a note. That this I is basically y. Y is from 1 to minimum of 2 star x and m, and y plus plus ci as y. So if y XOR x is equal to 0, then basically they are both equal, right? So we don't want that. So in that case we'll continue. Otherwise, if x is divisible by y, if x is divisible by y, okay, so, oh, not y, sorry, x is divisible by x XOR y. So x XOR I is basically y here. So x XOR y, if it is divisible by x XOR y, otherwise y itself is divisible by x XOR y, then basically you will do answer plus plus and finally output the answer. And yep, pretty easy question and pretty short video as well. I hope you enjoyed solving the question and listening to the solution as well. Thank you for watching. And yep, this video was made because of one of our subscribers. Actually, I don't know his subscriber or she's subscriber or not, but yeah, it is because of that person's wish. But yes, Thank you for asking the question, and thank you for listening to the solution. If you find it useful, please consider liking the video and staying subscribed to the channel. Thank you again.